Good day, students. Welcome to SS1 Totem Physics class. My name is Uzochukwu Bartholomew Onwobane. The topic for today is current electricity. Current electricity 1. Specific objective. At the end of this class, you should be able to 1. Define electric current, potential difference, resistance. State Ohm's law. Identify the electrical symbols of some circuit components. Solve simple problems. Electric current is the topic this morning. I would like you also to pay attention to some of the fonts you're seeing. Some of the fonts that are colored are not just for beautifications, but they are very important. These are things that when they are lacking in definitions, they won't be complete. So pay attention to those colors. They are important elements to those definitions. Topic: current electricity. A current is the motion of charges from one region to another in an electrical circuit. When charges flow, they constitute current. The conducting part through which this current flow is called circuit. When charges flow, they constitute current. In the previous class, we have done static electricity, and when we talk about static electricity, we are talking about charges that don't move. They remain in the body. But when these charges start moving, they now constitute what we call current. They are not charges in motion, and when charges are in motion, they constitute current. Definition: what is an electric current? An electric current is the time rate of flow of charge round a circuit. An electric current is the time rate of flow of charge round a circuit. Electric current is equal to quantity of charge over time. It is mathematically expressed as quantity of current all over time. Now we have it that I is equals to Q over T. We know it that I is the current, Q is the charge, and T is time. If you make Q the subject of formula, we have it that Q is equals to IT. The unit of charge is coulombs. That's C. The unit of time is seconds. Therefore, the unit of current, coulomb per seconds, is equals to 1 ampere, which is the SI unit of current. The SI unit of current is ampere. The instrument used for measuring current is called ammeter, while the unit of current is ampere. The instrument for measuring current is ammeter, while the unit of current is ampere. Simple circuit. These are not abstract things. These are little things you could do in your house. If you look at this diagram, you discover that this is just a cell. A cell was connected with wire, and a bulb was connected to it, and a switch was connected to it. This is things you do to play with. So this is a simple electrical cycle. What we call a cycle is not abstract. This is it, just the wire connection, the bulb, the switch, and the cell, which is generating the current. This is it. Now look at the symbols. The third diagram is the symbol showing you how a cell is represented, or a battery. Then we have the light, which is there. Then we also have the switch. When it is more than a cell, it's called a battery, but this is a cell. Now let's take an example. A current of 12 ampere flows for 20 minutes into an electric cooker. How much charge has the cooker used? A current of 12 ampere flows for 20 minutes into an electrical cooker. How much charge has the cooker used? Now, like I told you in the previous class we had, the first thing to do is to write out what you are given in the question. If you look at the question, we are given current. A current I is equals to 12 ampere. Then the time for the flow of the charge is 20 minutes. But minutes is not the SI unit of time. Therefore, you convert it to seconds. So therefore, it is 20 times 60, which is equals to 1,200 seconds. Now, we're looking for charge. Charge is equals to IT. That's Q is equals to IT. That's current times time. Therefore, Q is equals to 2F, which is the current, times 1,200 seconds. The Q is equals to 14,400 coulombs. That is the charge. Let's move over to potential difference. Now, what we call potential difference? When current flows through a wire, a potential difference is developed between the ends of the wire. When current flows from the cell through a wire, potential difference is developed. Now, what is potential difference? Potential difference between any 2 points in a circuit is defined as the work done in joules when 1 coulomb of charge moves from one point to another. I repeat, potential difference, that's PD, between any 2 points in a circuit is defined as the work done in joules when 1 coulomb of charge moves from one point to another. Now remember, even while we are doing work done, you know that for work to be done, there must be a change in position. So when these charges change position and begin to move, when they move, we now say that that work that is done by those charges is what we call potential difference. So it is the work done in joules when a coulomb of charge moves, 1 unit of charge moves from one point to another. That is potential difference. The unit of potential difference is volt, and the instrument used for measuring potential difference is called voltmeter. The unit of potential difference is volt, and the instrument for measuring potential difference is called voltmeter. Potential difference is usually connected in parallel in a circuit. Resistance. Resistance is the opposition to the flow of current in a circuit. Resistance is the opposition to the flow of current in a circuit. It is measured in ohms. It is measured in ohms. Resistance is the opposition to the flow of current. It is measured in ohms. The circuit component that offers opposition to the flow of current is called a resistor. What is causing the opposition? That component causing the opposition is what we call the resistor. But the opposition to the flow of current in any circuit is what we call resistance. There are 2 types of resistors that you can find in any circuit. The first one, we have what we call the standard resistor, and the second one is what we call the variable resistor, or we call it the rheostats. The standard resistors are resistors whose resistance is accurately known. These are resistors in which their resistance is accurately known. It is known, it is written. If you get a standard resistor, it is written on it the value of the resistance. That's the strength of the resistance is written on it. For variable resistors or rheostats, their resistance can be varied. You can vary the resistance to the amount you need, or the strength of the resistance you need. You can vary it. It is not just a particular resistance. You can use it. If you want 2 ohms, you can vary it to 2 ohms. If you want 10 ohms, you can move it to 10 ohms and get the resistance you want. Resistors can be made from materials such as manganese or constantine. Materials that are used for producing resistors are manganese or constantine, or even carbon materials. Ohms Law. Ohms Law. Experiment shows that there exists a relationship between the current flowing in a conductor and the potential difference at its ends. This relationship is what we call Ohms Law. Experiments have shown that there's a relationship between the potential difference and the current when current flows in a conductor. Now, and that relationship is what we call Ohms Law. What is Ohms Law? Ohms Law states that the electric current passing through a metallic conductor or wire at a constant temperature is directly proportional to the potential difference applied between its ends. I repeat, Ohm's law states that the electric current passing through a metallic conductor, that's a wire, at constant temperature is directly proportional to the potential difference applied between the ends. Note, at constant temperature. If the temperature is not constant, therefore Ohm's law will not be obeyed. Now we have it that Ohm's law can be expressed mathematically as potential difference is directly proportional to current. That is, V is directly proportional to I. Therefore, remember in mathematics or in physics, to remove proportionality sign, you introduce a constant. Therefore, we have it as V equals to IR. The constant that was introduced is I. Now, that constant that was introduced is a constant of proportionality, which is called the resistance. It is the resistance. R is the resistance. Therefore, we can state Ohm's law as V equals to IR. Some circuit components and their symbols. This is to help you identify some circuit components so that when we start calculating or we start seeing some diagrams, we will not be confused. Now, if you look at the first thing we have here is what we call an open switch. The switch is open. It's an open switch, and the one below it is called a closed switch. A closed switch. The one adjacent to it is the battery, you discover, and the one below it is called the cell. When we connect more than a cell, it becomes a battery, but one of it is called a cell. Look at also, you see the diagram of the bulb. This is a diagram of a bulb. Now, a lamp or a bulb. When you see things like this in circuit, you should know that they represent either a bulb or a lamp. Also, we'll see this one, you have A inside it. You see the cycle with A and some wires connect these two lines to it. This is called an ammeter. Now, this one, if you come very close down below, the last line you discover we have a fuse. There's a symbol of a fuse. But now, also, I would like you to look at this. We have two diagrams here for resistor. Whichever one you see in a circuit is correct. It's either this box or this other one. They are all resistors. Then we have this cycle where we have two lines attached to it, and we have a V. It is the symbol for the voltmeter. When voltmeter is connected in the circuit, this is what you're going to see. There are also other circuit symbols. You can confirm them from your textbooks, but these are the simple ones you always see. Resistors in series and parallel. Now, resistors can either be connected in series or in parallel. Now, let's look at resistors in series. Resistors are said to be in series when they are connected end to end, as shown in the figure below. If you look at the figure below, the resistors are connected end to end. When resistors are connected in series, the same current flows through them, but the potential difference across the resistors differs. Please note this. When resistors are connected in series, the same current will pass through the four resistors, but the potential difference across the four resistors are different. Now, therefore, when resistors, as shown in the figure below, are connected in series, you will now discover that the equivalent or the combined resistance can be calculated as follows, that R is equals to R1 plus R2 plus R3 plus R4. This is when they are connected in series. They can just be added together. R1 plus R2 plus R3 plus R4 will give you the combined, or what we call the equivalent resistance. Parallel resistors in parallel or parallel connection of resistors. Resistors are connected in parallel when they are arranged side by side, such that their corresponding ends join together at two junctions, A and E, as shown below. If you look at this diagram below, you now discover that the resistors are connected side by side. R1, R2, R3, and R4 are connected side by side, but their corresponding ends are joined at A and E. When you see such a diagram, you know that these resistors are connected in parallel. So they are connected side by side and their ends are joined together at a point. Please note this. If in such arrangement, in such arrangement as shown below, the potential difference across the resistors is the same, but currents through each resistors differ. If you look at below, you now discover that the currents coming from the cell was initially I, but when it comes to the junction of A, they're all divided into I1 goes to R1, I2 goes to R2, I3 goes to R3, and I4 goes to R4. The current split, but when they come to A, they combine together. So you now discover that the current passing through the resistors are different, but the potential difference across the resistors are the same. Therefore, when resistors are having such arrangement, we can get the combined resistance or the equivalent resistance as 1 over R equals to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. This is the equivalent resistance when they are connected in parallel. Now let's solve questions on resistance in parallel and resistance in series. Example 1. 3 resistors of resistance 1 ohm, 2 ohms, and 4 ohms are connected in series. Find the equivalent resistance. 3 resistors of resistance 1 ohm, 2 ohm, and 4 ohms are connected in series. Find the equivalent resistance. Since they are connected in series, you just simply do an addition of the 3 resistance. Now you'll discover that we'll go back to the resistance in series. We'll have that R is equals to R1 plus R2 plus R3, where R1 is 1 and R2 is 2 and R3 is 4. Therefore, it is R is equals to 1 plus 2 plus 4, which is equals to R is equals to 7 ohms. The equivalent or the combined resistance is 7 ohms. Example 2. If 3 resistors, 2 ohms, 3 ohms, and 5 ohms are connected in parallel in a circuit, calculate the equivalent resistance of the combination. If 3 resistors, 2 ohms, 3 ohms, and 5 ohms are connected in parallel in a circuit, calculate the equivalent resistance of the combination. Now, if resistors are combined, have a parallel connection, you now discover that the equivalent resistance will be calculated as thus. 1 over R is equals to 1 over R1 plus 1 over R2 plus 1 over R3. Now we have it that 1 over R is equals to 1 over 2 plus 1 over 3 plus 1 over 5. For you to be able to calculate this, you have to look for the LCM. The LCM of 2, 3, and 5 is 30. Now when you get the LCM, you now discover that 2 will go into 30 15 times. 15 times 1 is 15 plus. Now we now also have it that 3 will go into 30 10 times. 10 times 1 is 1. And also we have it that 5 will go into 36 times. 6 times 1 is 6. So we now have it is 15 plus 10 plus 6, which is over 30, which is equals to 31 over 30. But we're not looking for 1 over R, we're looking for R. Therefore, we find the reciprocal of both sides. Looking for the reciprocal of both sides, therefore, we now have it that R is equals to 30 all over 31. The 30 comes up while the 31 goes down, and R goes up also. Therefore, we now have it that R, if you punch your calculator, you now discover it to give you that R is equals to 0.97 ohms. Example 3. 4 resistors are connected in parallel. The equivalent resistance is 4 ohms. 4 ohms resistors are connected in parallel. The equivalent resistance is, you will discover that we have 4 resistors. Each of them is 4 ohms. They are connected in parallel. Therefore, the equivalent or the combined resistance will be 1 over R equals to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. Now, we have it that it is 1 over R is equals to 1 over 4 plus 1 over 4 plus 1 over 4 plus 1 over 4. Now, the LCM simple is just 4. We now have it is 1 plus 1 plus 1 plus 1 plus 1. Therefore, 1 over R is equals to 4 over 4. And R is equals to 4 all over 4. We're not looking for 1 over R. We're looking for R. So R is equals to 4 over 4 when you take the reciprocal of both sides. And therefore, R is equals to 1 ohm. Calculate number 4. Calculate the equivalent resistance of the diagram on the screen. Now, if you look at the diagram very well, study the diagram very well, you now discover that we have the first we have 2 ohms. Then the second side we are having 3 ohms, 4 ohms, and 5 ohms. Now we have a parallel connection of the 3 ohms, the 4 ohms, and the 5 ohms. But when you look at the diagram, you now discover that the 3 ohms, the 4 ohms, and the 5 ohms are in series combination with the 2 ohms and the 6 ohms. For you to resolve the diagram, you have to first of all resolve the parallel connection, which is the 3 ohms, the 4 ohms, and the 5 ohms. Now let's start with the parallel connection in the diagram. Now, the equivalent resistance of this parallel connection is 1 over R equals to 1 over R1 plus 1 over R2 plus 1 over R3. Now where R1 is 3, R2 is 4, and R3 is 5. Therefore, I have 1 over R1 is equals to 1 over 3 plus 1 over 4 plus 1 over 5. What you look for the LCM. The LCM of 3, 4, and 5 is 60. Therefore, I have it that 1 over R is equals to now 20 plus 15. Because when you look for the LCM, you now discover that 3 will go into 60 20 times. 20 times 1 is 20 plus 15 will go into 60. 4 will go into 60 15 times, and 50 times 1 is 15. And also we now discover that 5 will go into 60 12 times, and 12 times 1 is 12. Then we now have it that 1 over R is equals to 20 plus 15 plus 12 all over 60. Therefore, we now have 1 over R is equals to 47 over 60. But we're not looking for 1 over R, we are looking for R. Therefore, you find the reciprocal of both sides. When you look for the reciprocal of both sides, R is now equals to 60 all over 47. And when you use your calculator, you now discover that our R is equals to 1.28 ohms. 1.28 ohms. Having resolved the parallel combination, you now discover that the combination is now in series. We now have that the 2 ohms, the 1.28 ohms, and the 6 ohms are now in series. Therefore, you cannot just add them. We now have it that R is equals to R1 plus R2 plus R3. Now, our R1 is now the 2 ohms. Our R2 is now the calculated 1.28 ohms. And R3 is now the 6 ohms. Therefore, we now have it that R is equals to 2 plus 1.28 plus 6. And our equivalent resistance R is equals to 9.28 ohms. Evaluation. I would like you to answer some of these questions to see how far you have assimilated the class for today, how far you have understood the class. Therefore, I'd like you to answer. The first question here we have here is define the following. A. Electrical current. B. Potential difference. C. Resistance. Number 2, I would like you to state Ohm's law. Number 3 is calculation. I would like you to calculate the following. Number 3, find 5 ohms resistors are connected in parallel. The equivalent resistance is 5 ohms resistors are connected in parallel. The equivalent resistance is number 4. If a current of 0.5 ampere flows through a circuit for 120 seconds, how much charge will have passed into a component in the circuit? I repeat. If a current of 0.5 ampere flows through a circuit for 120 seconds, how much charge will have passed into a component in the circuit? Lastly, number 5. Find the equivalent resistance of this combination. That's the diagram you're seeing on the board, on the screen. Find the equivalent resistance of this diagram. We have it that we have if you look at the diagram very well, you discover that we have 2 parallel connections. The first parallel connection is the 2 ohms and the 1 ohms. You have to resolve them first, and also resolve the 3 ohms, the 5 ohms, and also the 5 ohms. They are also in parallel connection. Resolve them, and when you resolve them, you now discover that everything will not be in series. Therefore, you cannot get the combined resistance or the equivalent resistance. I'm on air. I can't wait for you to finish the question. I would like you to solve the question using your own time there. So, but for now, I'm going to proceed. In conclusion, electric current is the time rate of flow of charge around a circuit. Electric current is the time rate of flow of charge around a circuit. I told you while I was teaching that the electric current is measured in ampere, and the instrument used for measuring the electric current is ammeter. An ammeter is usually connected in series in a circuit. Note that ammeter is usually connected in series in a circuit. Now, number 2, potential difference. The potential difference between any 2 points in a circuit is defined as the work done in joules when one coulomb of charge moves from one point to another. The potential difference between any 2 points in a circuit is defined as the work done in joules when one coulomb of charge moves from one point to another. The potential difference is usually measured in volts. That's the unit of potential difference is volts, and the instrument used for measuring potential difference is voltmeter. And voltmeter is usually connected in parallel in a circuit. Number 3, resistance. The resistance is the opposition to the flow of current in a circuit. It is measured in ohms. Resistance is the opposition to the flow of current in a circuit. It is measured in ohms. Resistor. Resistor is a circuit component that offers opposition to the flow of current. Resistor is a circuit component that offers opposition to the flow of current. Now, I want you to remember that the opposition to the flow is the resistance, while the component that offers the opposition is the resistor. We have 2 types of resistors. We have the standard resistors, the variable resistors. The standard resistors are resistors whose resistance is known, is accurately known, it is fixed. While the variable resistors, their resistance can be varied. It is not fixed. They are also called rheostats. Ohm's law. Ohm's law states that the electric current passing through a metallic conductor or a wire at a constant temperature is directly proportional to the potential difference applied between its ends. Ohm's law states that the electric current passing through a metallic conductor or wire at a constant temperature is directly proportional to the potential difference applied at its ends. I would like you to source other materials and textbooks so that you can get further knowledge and solve exercises in those textbooks. If there is any question or questions that are difficult for you to solve, I would like you to forward it to the email on the screen, ozobato2@gmail.com. ozobato2@gmail.com. Thank you. God bless you.